Hey everyone. So onwards to lesson 8, which is the third part of factoring trinomials that we've been talking about. So if you understood yesterday's lesson, where I introduced the concept of decomposition, today is not going to be hard at all. Okay. Yesterday was the toughest thing that we're going to deal with as far as factoring. Today is about looking at a special case of trinomials where you can actually go about it a little bit quicker. You don't have to go through the whole process of decomposition, okay? So it's a shortcut. Shortcuts are great if you know when to use them. My one concern about shortcuts is that sometimes students mix up when you are allowed to do the shortcut and when you're not allowed to do the shortcut. So if you happen to be one of those students where you think, this shortcut's gonna mess me up, I'm gonna use it in the wrong spot, don't use it. Decomposition will always work, okay? The thing we did yesterday where you're finding two numbers that multiply together to give you the outsides and add together to give you the insides, that will always work, okay? So if shortcuts are going to confuse you, go through these examples without using the shortcut, do them with decomposition just as a way of practicing decomposition. So let's begin by looking at a review of what we did yesterday, a review of decomposition. I'm looking at 5m squared minus 7m minus 34. 5 times negative 34 is negative 170. So I'm looking for two numbers that multiply together to give you negative 170 and add together to give you negative 7. They would be 17 and 10, where 17 is negative. So I break my negative 7 down into negative 17m and my 10m. Remember, whatever letter went with the number, that letter has to be with both of the numbers that you're decomposing into. So that leaves me with 5m squared minus 17m plus 10m minus 34. Now I'm going to factor the front two, factor the back two. I can take out an m from the front two. So that would leave me with m bracket 5m minus 17. And then from 10m and negative 34 out of the back two, I can take out a 2. So that would leave me with 5m minus 17 again. Now, that's awesome. That's what I wanted to happen. 5m minus 17 is now a common factor in both of those terms. And so I'll factor it out and be left with 5m minus 17 times that m plus 2. Okay, so that's what we spent a lot of time yesterday trying to get you super comfortable with. All right, now, so today we're going to talk a little bit about a shortcut. D squared minus 9d plus 18. Can you go factor that for me? I'm looking for two numbers that multiply together to give you 18, add together to give you the negative 9. That would be negative 6 and negative 3. So I'm going to decompose my negative 9d into negative 6d and negative 3d. I'm going to factor the front two and factor the back two. So out of the front two, I can take out a d, and that would leave me with d minus 6. And out of the back two, I can take out a negative 3, and that would leave me with d minus 6 again. And so I end up with d minus 3, d minus 6. I could have asked you that question yesterday. The process that I just did is exactly the same as what I showed you yesterday. But now we want to just talk about this for a little bit. What do you notice about the two friendly numbers you chose and the numbers that are in your binomial product? So we chose those two friendly numbers, a negative 6 and a negative 3. And then the numbers that are in our binomial product are, negative 6 and negative 3. They're the same numbers, okay? What's special about this trinomial compared to all the ones we worked on yesterday? The difference with this guy is there was no number in front of the d squared. It was essentially just a 1, okay? So when there's no coefficient in front of the x squared term or the a squared term or the d squared term or whatever, when there's no coefficient there, you don't actually have to go through the process of decomposition. You can actually use a shortcut and go straight to your answers. Your two friendly numbers will be the back numbers of your binomial, okay? Again, though, if you think that that's going to confuse you, well, I just showed you, right? Decomposition is always going to work. You can always do decomposition, and that's always fine, okay? Does the order of how you write your factors matter? Does it change anything? So this d minus 3 times d minus 6, would that have changed if I wrote it as d minus 6 times d minus 3? The answer to that is no. 2 times 3 and 3 times 2 are both 6. The order of multiplication doesn't matter. Okay, so the shortcut is when there is no coefficient on the x squared term, the two friendly numbers you find become the back two numbers in the binomial product. So let's give it a try. X squared plus 5x plus 6, I'm looking for two numbers that multiply together to give me 6 and add together to give me 5. This is shortcuttable because the coefficient on my x squared is just a 1. The two numbers are 2 and 3, so I'll go right to x plus 2 and x plus 3. Okay, for the blue guy here, I'm looking for two numbers that multiply together to give me -6 and add together to give me 1. This is shortcuttable because the coefficient on the a squared term is a 1. So two numbers that multiply together to give me -6 and add together to give me +1 would be +3 and -2. So I can go straight to my answer and I'd have a plus 3 and a minus 2. The last example on this slide, I'm looking for two numbers that multiply together to give me -6, add together to give me -5. Again, this is shortcuttable because there's no coefficient on the g squared. Those two numbers would be -6 and +1, so I break it down into g minus 6 and g plus 1. Okay, remember you cannot do this if the coefficient on the front is not a 1. Okay, then you're right back to having to use decomposition, which is what we talked about yesterday. Okay, x squared plus 10x plus 24. I'm looking for two numbers that multiply together to give me 24 and add together to give me 10. Those are 4 and 6. This is shortcuttable, so my answer becomes x plus 4 and x plus 6. B squared minus 7b minus 30. Looking for two numbers that multiply together to give me -30 and add together to give me -7. This is shortcuttable because the coefficient on the b squared is 1. And my numbers are -10 and +3, so I end up with b minus 10 and b plus 3. Now, at first glance, this last guy here, you might say, hey, that's not shortcuttable, but remember, the first step in any factoring question is always to look for a greatest common factor. In this one, it happens to be that all three of these numbers can be divided by 3, so I'm going to take the 3 out first. That's going to leave me with 3 times d squared minus 2d minus 48. Now I'm looking at that d squared minus 2d minus 48 and asking myself, okay, can I continue? Can I continue to factor this? Is there two numbers that multiply together to give me -48 and add together to give me -2? And there are. It's -6 and -8 and +6. Okay, -8 and +6. Now this portion is shortcuttable because there is now no coefficient on the d squared. Remember that the 3 came out first. The 3 stays there. It's along for the ride. It must be part of my answer. And so my final answer becomes 3 times d minus 8 times d plus 6. Okay? Awesome. I told you today would be better than yesterday. Okay, completely factor the following if possible. X squared minus 14x plus 49. Looking for two numbers that multiply together to give me 49 and add together to give me -14. This is shortcuttable. And we're looking at -7 and -7. So that would be x minus 7 and x minus 7. -7 times -7 gives me a +49. -7 plus -7 gives me the -14. Now, this guy's special, like my mom told me I was. The x minus 7 is essentially being multiplied by itself. So we take this one step further. Instead of saying x minus 7 multiple times, we would conclude that it's x minus 7 all squared. Okay, now, if you like words, this is called a perfect square trinomial because it has as its square root a binomial times itself. Okay, tomorrow we're going to talk about special trinomials, and this is one of the groups of special trinomials that we're going to talk about, perfect square trinomials. Okay, completely factor the following. If you haven't paused me at all in this lesson, you should be pausing by now. You don't need me to go through this. You should go through it first and then come back and check your answers with me. Looking for two numbers that multiply together to give me 10. Add together to give me 7. That'd be 5 and 2. This is shortcuttable. So I got x plus 2 and x plus 5. Now remember, I'm not spending a whole lot of time on this lesson finding those numbers because we spent lots and lots of time yesterday finding those numbers. If you are wondering how those numbers are popping in my head, write them down. Remember, we said we have to go through the factors of 10. So we go 1 times 10, 2 times 5, 3 times whatever, 4 times whatever, 3 and 4 didn't work. That got us to 5, and 5 was already there, and then we could find our pair. Okay. Okay. X squared minus 8x plus 15. Looking for two numbers that multiply together to give me 15 and add together to give me negative 8. That would be negative 3 and negative 5, and this is shortcuttable. So we end up with x minus 3 times x minus 5. I want you guys to be like factoring machines by the time this is all over, okay? Remember I said this is like one of the most important concepts you can learn in all of grade 10 is how to be really, really comfortable factoring. Okay, now determine the possible values for k so that the following trinomial is factorable. Now, what you need to see here is I would be looking for two numbers that multiply together to give me 20, and then they would add together to give me k. Well, then I need to start thinking about numbers that multiply together to give me 20. 1 times 20 gives me 20. So if my numbers were 1 and 20, what would k be? Well, k would have to be 1 plus 20, so 21. If I was looking for two numbers that multiply together to give me 20 and add together to give me 21, this would be factorable because I know I have two numbers that multiply together to give me 20 and add together to give me 21. You follow what I'm doing? Okay. So I could do 1 and 20, and then k would be 21. I could do 2 and 10, and then that would mean k is good, 12. I could do 3 and nothing, right? 20 can't be divided by 3. I could do 4 and 5, and then k would be 9. Now, my question to you, before I put anything else on the slide here, is that it? And the answer is no, because not only could I go 1 times 20, I could go negative 1 times negative 20. Negative 1 times negative 20 is still positive 20, okay? So what would that make k be? K would actually now be negative 21, okay? And I could do that for the other two examples as well. So what I end up doing is the following. Then my 2 times 10, my 4 times 5, and I just lumped that in with k because it could be negative 2, negative 10, and negative 4, negative 5. Okay? All right, last question for this lesson. Determine the possible values of k so that the following trinomial is factorable. Same sort of question, except this time I changed where k was. Now, I'm looking for two numbers that would multiply together to give me k, but add together to give me 7. So now what I'm asking myself is, okay, well, what would add together to give me 7? Well, 1 plus 6 would give me 7. So what would k need to be? In that instance, k would need to be 6, 1 times 6. Okay. What else could I do? I could do 2 times 5, or 2 plus 5. 2 plus 5 is 7, which would make k 10. I could do 3 plus 4, that would make k 12. Now, is that it? Could I do 8 and minus 1? Would that give me 7? Yes. And so this is a very different one because actually there are an infinite amount of values for k. Okay, now obviously you can't come up with them all if there's an infinite amount. So if this question was on a test, it would probably say find 2 or 3 values of k that work. Okay. If the previous question was on a test, I would say find all the values of k that make this work. Okay, so these last two examples are a little trickier. They're a little more in-depth. They just require a little bit more thought. But the end result is still the same. You're still looking for two numbers that multiply together to give you the outside numbers multiplied together and add together to give you the middle guy. Okay? All right, so that's where we'll stop today. Tomorrow, we're just going to deal with some special cases of factoring, and then that'll be it for the unit. Good job, guys. In the meantime, try out your homework, and if you have any questions, feel free to connect with me. Thanks, guys. Awesome job.